All right, this section is on geometric sequences. In chapter 3, we talked about arithmetic sequences. So here's a couple examples. 1, 4, 7, 10, 13, it goes on like that. So you're adding 3 each time. So those kind of sequences are linear and end up with a graph like that. And here was the formula, if you didn't remember. So we had a sub n equals a sub 1, or the first term of the sequence, plus the number of the term minus 1 times the common difference. Today we're going to talk about geometric sequences. They end up functions like that rise steeply and quickly. The equation for those are a sub n equals the first term times the common ratio. That's what are the terms multiplied by or divided by to get to the next term, to the n minus 1 power, so the number of the term minus 1. So again, a sub 1 is the first term, r is the common ratio, or what you multiply by, and n is the number of terms. Here are some examples. 150, 25, 12 and a half. That's either multiplied by a half or divided by 2. This is times 3 times 3. So there's your common ratio. So if we look at these examples, we want to find out whether they are arithmetic, geometric, or neither. So if we go from 4 to 12 and 12 to 36, we are multiplying by 3 each time. So that's a common ratio. So this is geometric. Number 2, if you go from 1 to 5, that's plus 5, or plus 4. 5 to 10 is plus 5. 10 to 16 is plus 6, so that's nothing. That is neither. 4 to 2, 2 to 0, you are subtracting 2 every time. So this is arithmetic. It has a common difference. And then 400 to 200 to 100, you are dividing by 2. So that's geometric because you have a common ratio. Okay, so let's talk about the equations. So let's bring this over from the first slide. So your equation is a sub n equals a sub 1 times the common ratio to the n minus 1 power. So what we need to do is write an equation for the nth term of the geometric sequence. So we have a sub n equals the first term, and if you look at this, you're multiplying by -5 every time, so that's your common ratio. And then we have the number of the term minus 1. It's as easy as that. So number 2, we have a sub n equals the first term, which is 4, and then we are multiplying by 5 every time. That's the common ratio, the n minus 1 power. And this one's interesting. So I would take 48 and divide by 72, and 32 and divide by 48, but you get this, which is 2/3. So your common ratio is 2/3. So I have a sub n equals, my first term is 72 times the common ratio, which is 2/3 to the n minus 1 power. Okay, so number 1, the first term of a geometric sequence is 1. So let's just list out what we have. We have a sub 1 equals 1, and the common ratio is 9. So r equals 9. So let's put it in our formula first. I have a sub 8 equals, the first term is 1, the common ratio is 9, and then we have 8 to the 8 minus 1 power. So a 8th term is equal to 1 times 9 to the 7th power. So when you put that in your calculator, it'll be 4,700. Well, wait, let me read that the right way. Hold on, let me write it first. Oh, there we go. So that is 4,782,969. Number 2, the first term of the geometric sequence is 1/2, and the common ratio is 2. What's the 10th term? So the first term is 1/2, and the common ratio is 2. So we have a sub 10, which is the 10th term, is equal to 1/2 times 2 to the 10 minus 1 power. So let's simplify a little. Take 2 to the 9th power first. So 2 to the 9th power is 512. And if you take half of that, the 10th term is 256. All right, 3 is interesting. It gives you the third term of the sequence. So 1, 2, 3. The third term is 81. And the common ratio is 3. What's the first term? So let's find the first term. So we're going to take 81 and divide by 3, which gives us 27. And we're going to divide that by 3, which gives us 9. So the first term is 9, and the ratio is 3, common ratio. Now we want to know what the 12th term is. So we have the 12th term is equal to 9 times 3 to the 12 minus 1 power, which gives you 3 to the 11th power. I'm going to do that first. And you're going to multiply by 9. Gives me this number. 1,594,323. And that's it for today. This was a short one.